In this video, we're going to continue our factoring, looking at a case of difference of squares. And this is going to be a factoring method we try to apply when we see two terms, so a binomial where there's subtraction, and we potentially can take the square root of both terms within the binomial. So a very simple formula of this says a squared minus b squared equals two factors, a plus b and a minus b, where you might notice the two factors have the exact same values within them, except one is plus and one is minus. And this all stems from examples that we've been multiplying so far, where we have matching values. So maybe a case of this would be something like x plus 3 and x minus 3, where we have a case where both factors look the same except for the addition and subtraction. And when we multiply them, we take x times both terms here, and we get x times x is x squared. And then the x times the negative 3 is negative 3x. But when we multiply the 3 into this, we get 3 times x, which is positive 3x. And so we have this negative 3x and positive 3x, which will cancel each other. And then we continue multiplying, and we have 3 times negative 3, which is negative 9. And so this is one of those special products that only gave us a two-term polynomial. And so the idea here is recognizing that when we get a two-term polynomial, it might just factor right back to that special setup that we've been talking about. And so the way this works is we see that we have two terms here and minus. The question then becomes, are we able to take the square root of this as well as this? And the answer is yes. We see that the square root of x squared will be x, and the square root of 9 is 3. And so to apply the formula, very simply, to figure out what value we use for a in the beginning of these factors, we simply take the square root of our first term, known as a squared. And then to know what value to use for b, we simply take the square root of the second term, which is b squared. And then if you need more examples later on, there is a YouTube playlist put together with some other people factoring some polynomials here. So going down here, let's try factoring then. We have, in case here, for example 4, we have y squared minus 25. And you might notice that we have subtraction. We have two terms, just like this, set up here. And we should know the square root of both terms. And so if we want to factor this, it seems that we have two squared terms here and here. And so to factor, we take the square root of our first term, y squared, which is y, and we take the square root of our second term, not the minus sign. The minus sign is just telling us that we can use this formula. Just take the square root of the 25, and we get 5. So when we go to factor this, we have two factors that are identical to each other, except one has addition, the other subtraction. They will both start with a, and so a for us was equal to y. They both end with b, which is 5. And so we have two factors here, y plus 5 and y minus 5. When we multiply those back together, we end up with the polynomial y squared minus 25. Then we go to case 5 here, and we try to use the same idea. We see it's a binomial, just two terms. And we think about this. Do we know the square root of both terms? Well, you could try taking the square root of 18, but you're going to run into an issue. We don't actually know the square root of that. It's not an integer value anyway. We could simplify it, which we'll learn at a later time, but we don't know the square root. So the question is, what do we do at this point? Well, something we've discussed is to check for a common factor. So when a strategy doesn't work right away, it doesn't mean it's never going to work. Maybe what we need to do is just see if our factors, our terms have anything in common. In this case, I see both terms are even. I know I can at least divide them both by 2. And I think if we just do that, just divide by 2, our first term will now say 9b squared. Our second term will say 64. And there we have a case of a binomial with subtraction, and we know the square root of 9 and the square root of 64. So we're able now to continue on using our new formula here for factoring a binomial. Okay, so let's go ahead and try that. This 2 we don't need at the moment, but we will use it as part of our factors. It was part of our original polynomial there, but we just need to focus on what we have rewritten inside these parentheses. So we have 9b squared and 64. A is the square root of your first term, so square root of 9b squared, which is 3b, and b is the square root of 64, which we know is 8. So to get our two factors, simply set them up where one has addition, the other subtraction, and they will both start with 3b, and they will both end with 8. And yes, those multiply back to the 9b squared minus 64, but if we don't keep this 2, we'll never get back to the numbers of 18 and negative 128. So make sure that we keep track of our common factors. Okay, so let's try this one more time. An example that has higher exponents here, which we will work with more next semester. And we see that there are two terms. We have subtraction, and believe it or not, we do know the square root of both. When we look here, a would be the square root of x to the fourth. And we haven't worked a lot with this, taking square roots with exponents. But if we just think of what a square root means, the square root of a value is equal to something based on if that result times itself gives you what was underneath the square root sign. And in this case, if we think about it, x squared times another x squared would give us x to the fourth. And so we do know the square root of x to the fourth. A general rule is if our exponent is even, we can take the square root of it. Now, a little more obviously, we have the square root of 16, and we know the square root of that is 4. So our two factors then would both start with x squared and both end with 4. One will have addition, the other subtraction. But wait, there's more, because as you look at this, you might notice that the exponents are a little bit higher than we're used to. When we factor, we've been seeing a lot of just b's and y's and x's, nothing with an exponent higher than 1. And in this case, we have exponents of 2. And when that happens, there might be an opportunity to factor again. So as you look at these, you see that we have two terms, so binomial, which is what we were just practicing, and one of them has a minus sign, just like we have been practicing. So we actually can't do anything to this first factor because there's a plus sign here. And what we're discussing right now is all about subtraction with square terms. But this one has two terms with subtraction, and we know the square root of each of those terms. So this second factor here is something we can break down a little bit more. A would be the square root of x squared, which is x. B is the square root of 4, which is 2. And our factor from that would say x plus 2 and the matching x minus 2. And we need to keep our original factor that no longer broke down, but it is needed to get back to our original polynomial that has an x to the fourth. And that is just a case right there, something that we don't see often, but it is possible, a case where we can break down a little bit more after we've already factored one time. So that is how this is going to work with difference of squares. It doesn't get any more complicated than that. It's just recognizing that we can take the square root of some values here. So the only thing left for us to do is a little comparison here between, in this case, two trinomials. And you might notice that in both trinomials, the setup is essentially the same, where we have three terms. They both use k's. They both have the coefficients of 1, negative 13, and 36. But the difference is one of them has smaller exponents than the other. So the question here is, what implications are there from that if the exponents are different? Well, good news is we can still work it the same way. They're both trinomials, so to factor, we can still try split the middle. So the process there is the same. And when we fill out this chart here, a times c is a little bit basic again because a is equal to 1. So when we take 1 times 36, we're going to get 36. And b is negative 13. And those are the same values we get here. A times c is still 36. B is still negative 13. Okay, so everything there is the same. Strategy-wise, if we're going to multiply to a positive value and combine to a negative value, we would have to have two negative numbers. So I'm not going to make the whole list here. I am just going to go ahead and jump to the two numbers that we're going to need. That would be negative 9 and negative 4. They multiply to positive 36 while simultaneously also combining to negative 13. So those are the two numbers we want in whatever can be put into both columns. Okay. So we have our two values we're going to use. We have a trinomial. We will split the middle. Let's go ahead and try that again. Over here we have k squared minus 13k plus 36. And here we have k to the fourth minus 13k squared plus 36. Split the middle is going to be the same idea in each setup. We have our negative 4k, our negative 9k. And the reason that is these two terms here, this is the whole idea of split the middle. We are finding two terms that combine back to what we originally had. Negative 4k minus 9k is negative 13k. We are just rewriting that middle term. So we'll use a similar idea over here. We're going to split the middle with our negative 4 and negative 9, but we need to combine back to k squared. And so we are going to keep these as k squared. Because from what we've decided, from what we've discussed, when we combine like terms, the exponents do not change. And so to combine back to a negative 13k squared, we need to have these two terms both say k squared, so they can combine back to that. But other than that, everything else seems to be working the same. We keep the first and the last terms as they were. So k squared and a plus 36. Over here we have k to the fourth and a plus 36. And we see that we have four terms now, so we can split this into two halves. And we just look for what is it that the halves have in common. So in this case, both halves can be divided by k. And when we do that, we can rewrite it as k times k minus 4. Here, similar, they both have k, but because the exponents are higher, we can actually divide both of them by k squared. To where the rewrite says k squared times, remember our rule for dividing was subtract exponents, 4 minus 2 is 2, so we get k squared minus 4. And the second half, pretty similar, we can divide both of these values by negative 9. So the rewrite would be negative 9 times k minus 4. So again, we divide by negative 9 to make this factor cancel what we had earlier. Or match what we had earlier, sorry. And over here, again, notice that the steps are basically identical in each of these scenarios. It's just different exponents that we might have present because we're going to divide by negative 9 here as well. And when we do that, the rewrite will say negative 9 times k squared minus 4. Okay, and so when we see those matching factors, we can rewrite, and this would be k minus 4. And the question is, what do we have left afterwards? And for us, we would have a k in red and a minus 9 in blue. Here, those two factors. And something similar here, we have a k squared minus 4 and a k squared minus 9. So both factors start with k's and they both end with minus 4s and minus 9s. But over here, again, the only difference we had in these two setups is the exponents are different. And as we've discussed earlier, when you have larger exponents, there's a chance that this can keep factoring. And that is what's happening here. In this second example, we have a difference of squares. We have two terms being subtracted, and we know the square root of both of them. So k squared minus 4 can actually factor again. So the square root of k squared is k. We know that our factoring with difference of squares has a plus and a minus. We take the square root of 4 and we get 2. And we can do the same with k squared minus 9. We have two terms being subtracted, and we know the square root of both of those terms. So we take the square root of k squared in this factor, which is k. We know that 1 will be a plus, 1 will be a minus, and the square root of 9 is 3. So this is another one of those cases where we have factors that have exponents higher than 1, and they were able to be factored again. So we always want to be careful and ask ourselves, can this factor further? Well, if you don't have any exponents that are higher than 1, then you know that you cannot. But when we have exponents higher than 1, we'll check and see if we can, and this is just one of those cases.